credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. We don't do that at all.
Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hey everybody, and welcome to the show. This is the Eavor Locksmith Show. I am your host, David Gibson, and I am so excited to be here with you guys today. We are unlocking the secrets to success in the oil and gas industry. One interview, one presentation, and one technical screw up on my part at a time. This is just an absolute amazing show. I finally got my teleprompter set up. So if I seem weird, like I'm not actually looking to the camera like I normally am, and it's a little off, it's because I'm trying to do this on the teleprompter, and let's see if it works. If hopefully it does. So I'm trying not to look at the monitor down here, trying to keep my eyes up here with everybody that's tuning in today. So a couple of special announcements to make, and I'm slightly out of focus. Do I need to? Oh, this is driving me nuts. Here's our technical problem of today. So let's just brighten this thing up, and hopefully autofocus will work when it's supposed to. Oh, this is getting aggravating. I think that's, nope. All right, so I had this all fixed before we went live. I think that's pretty close now. Yep. At least now I don't have to lean as far forward. All right. Thank you, Panasonic. Appreciate it. Really wish you guys, that's just a firmware thing. You guys could get that figured out. All right. Now we can turn that back down so I'm not washed out too bright. Is that working? All right. Better. That looks better. See, I'm still trying to just look at the camera lids, because if I look up and at myself, kind of slightly off where the teleprompter is. Probably teleprompter is too close. Maybe these are supposed to be set back, but if it's too far back, then I can't read it. The writing's small. I'm already wearing glasses. This is a challenge, but it's what happens when you take on challenges. You just have to overcome them, keep working through it, and tell everybody, hey, just relax. We'll get it on the next go round. All right. So thank everybody for being here. Today is definitely a special show, because today Keith Stelter is no longer on the show because he got a job. So congratulations, Keith. Really happy and excited for you to be joining the team over at Arc Energy. Look forward to what you guys have coming out in the future, and potentially being a sponsor of the show, maybe. So hopefully even some of those guys are still tuning in this week to be able to see what we've got on the program. Speaking on the program today, we've got Dr. Eric Van Oort, who's here today to talk about, we could be on the air for probably about 3 or 4 hours with all of the different things that he's done and that he could talk about. And so it's one of these things. It's like at some point in time, we'll just be like, all right, I think we're done. We'll just have to do a part 2 down the road or something. So let's get to it. Andrew says, good morning. Thanks for tuning in, sir. Carla says, good morning. Thank you for being here. A LinkedIn user. As always, you are the best. And there he is. Keith Stelter tuning in from Odessa, Texas. Yeah, guys, if this is your first time watching the show, let us know. Let us know where you're watching from. And if you've ever been a student or worked alongside Dr. Eric Van Oort, please let us know. I'd love to be able to hear about it. Brian Dugas tuning in from Bowbridge. Jorge's tuning in from Ciudad del Carmen in Mexico, or desde Ciudad del Carmen. If you guys haven't seen it and you want to see an absolute train wreck by me, go back and check out the all Spanish episode that we did with Luis Gonzalez from Merlin ERD about the 7 problems, or I think it was 7 problems, or just problems in drilling. It's actually a carbon copy to the episode that we did with Neil Armstrong from Merlin ERD about this time last year. That one's only on LinkedIn. I think we've screen captured it and we have it ready to be able to put onto YouTube. Try to get that done this next week, if at all possible. So Neil, tune it in. Next week, we've got Todd Brooker, who's going to be on the show teaching us about all kinds of things, evaluating reservoirs and mergers, acquisitions, divestitures, all kinds of cool stuff. LinkedIn users, it's the beer that keeps throwing everything out. Yeah, that is quite possible. Let me see here. I'm getting kind of lost. I'm trying not to. It's still weird to be doing this. All right, I've got to get used to the new setup. Scott McNeil, not just any old LinkedIn user. He's probably like one of the most active people as far as watching the show. He's supposed to have done it without you and all the support. I did nothing, sir. You did everything. We just loved having you on the show. Carlos says, congrats to Keith. Chris Montet, who's been on the show prior. He's a drilling engineer and now over at H&P, I believe. Right? So congratulations to Chris. We've got Stephen Truelove tuning in from Denver, Colorado. Who's this? Cohen. He says, congratulations to Keith. Cohen, I think that's how we say it. Todd says, great day today in Austin, Texas. Tonight, my daughter goal keeps in the Texas 6A high school state soccer final. Wow, 6A. That's like the top of the top right there. Well, good luck on that one. Hope she does well. Good morning from Calgary with Charles. We've got Nicholas Gossett watching from Austin, Texas. Dr. Van Oort was my drilling professor last semester. Well, Nicholas, thanks for being here. I remember him. He was at I went and spoke at the AADE UT chapter. I think it was like last winter. It was before COVID happened when we actually could do stuff in person. It was a lot of fun. We were there for like hours talking. Artie Morrison tuning in, professional new look. Great work, David. We've had it for a while now, Artie. You should have been tuning in, but thanks, man. I appreciate it. Yusuf, hey guys, missed the shows. Well, we missed having you here tuning in. Jack, thanks for being here. Where he says, drilling location in Texas, 8.5 miles from Old Mexico. All right, down near the border. Good try. All right, greetings from Abu Dhabi. All right, the international audience, well, from Tunisia, Samir in Spain, and Joshua, good morning, everyone, all the way from Arkansas. All right, guys, thanks everybody for being here. All right, on to the special announcement. So for a long time, I had been asking everybody, Jesus, thanks for being here, just watching on YouTube. Speaking of YouTube, I'd been asking everybody for quite some time to subscribe to the YouTube channel, right? And I was saying I was working on a special project. I was trying to get something done. And we finally hit the 1,000 subscribers, right? So the first metric was met, and that was because on YouTube you're not allowed to broadcast live from a mobile platform, right? To YouTube, right? Until you hit 1,000 subscribers, you've got to be special, right? So we've hit that. So now we can broadcast live mobilely to YouTube. Now I wasn't just going to broadcast live mobilely to YouTube, just any old way. We had to do something special. So here's the announcement. On Monday, make sure I get this right. I can't see the calendar from here. I think it's the 26th. I think that's right. Here, let me check here on my desktop. Make sure I don't want to. Oh gosh, I just got rid of everything. Come on. Yeah, 26. Okay, just making sure I get this right because I don't want to tell everybody the wrong date. So Monday the 26th. I'm not sure the exact time yet because we've got to be able to orchestrate a couple of things when we get there. But we're going to be going live, right? It's the first time this has ever happened in our industry, right? Nobody else has done this before. You want to be on leading edge and seeing some of the coolest stuff that we're doing in the industry right here at this show with me, right? We're going to be broadcasting live from a rig, right? A test rig in Oklahoma called Catoosa. We're going to be live streaming live from a rig with Catoosa. Now, some people might be saying, oh, well, that's okay. Well, it's not that special. Here's the special part. It's going to be, do this for you guys, in 360 VR. That's right. You're going to need to set one of these to be able to put on your head because we're going to be broadcasting live in 360-degree virtual reality for everybody out there. So you will be able to see whatever you want to see. It's not where the camera's pointing, it's where your eyes are going. This is good. Like, I'm super excited about this. I hope you guys are. This is the first time it's ever been done. Nobody else has done this. Nobody else has even come close to doing this, right? So this will be the first time live 360 VR. Get you one of these little things. You might even do the little Google Cardboard ones, or I think they even sell these at like gas stations now, right? I would say go buy them at Best Buy or something, but better off just buy it on Amazon. Give them a couple of bucks. These, seriously, this doesn't have you just need your phone, which most people do. Get your smartphone, right? Stick it in there, and then you'll be able to watch it live, 360 VR, right there, while we're out at the rig site. So, if I'm talking to somebody, right? Say I'm talking to Dwayne, right, from Catoosa. I'm talking to Dwayne. You could be over looking at the top drive or the drawworks or, down at the ground or out the V-door for all you you guys could be looking at whatever you want. There's an infinite number of views possible with this. I am super excited about this. I wish I could just go live straight off and do this, but then nobody would have these set up and ready to go, so it'd be kind of weird. So what I would recommend is find a spot on Monday. I'm not going to do it during, meeting times because then nobody would end up watching. We'll do it live. We'll probably do it noon or 1 o'clock. Most likely 1 o'clock is what I'm going to guess. Hopefully the weather is good. And get you a headset and get a swirly chair, and then you'll be able to spin around and see whatever you want at the rig site. We'll have the live going like this normally, and the separate camera so that we can see questions and stuff like that. If there's some place that you guys want us to be able to put the camera or answer some questions, we're still going to be able to do that. This is going to be absolutely bananas. I'm so excited about this. Nobody else has even come close to doing this. So anybody that says that, we're 10 steps behind them, sorry, we've paved the way so far ahead that the road started to erode back with vegetation. So, all right, guys, hopefully you guys think it's cool. Andrew says, I think it's cool. LinkedIn Studio says, that sounds cool. LinkedIn Other says, good morning, everybody. Oh, sorry. Somebody says, that's awesome. Let's see. Over under on the number of people who are VR into your rig and their actual reality rig. I don't know. I think that'd actually be cool. People that are in VR watching me at another rig while they're on a rig. It'd be rig inception of sorts. All right. Hopefully we see we will see some drilling actions. I don't think we're going to be able to see any drilling actions from a safety perspective, since we're going to be up there with the camera. We're going to be doing some things. We're going to make sure the rig's locked out, tagged out, and, can't have, we're doing this at Catoosa for a reason, because I doubt that there's any actual drilling company that would approve this. There's legal departments are way too busy doing stuff. What's happening, David? Ready for the show? Jason, thanks for being here. Arsenault. Jason Arsenault. See, got the name right. Andrew Crowder says bananas. Yes, it is bananas. Ray Kirk, we can go look for the key to the viewer. This is awesome. Ray, thanks for tuning in. I appreciate it. And then Arastu from Iran. I need to look up here. I keep doing this. This is the habit. I apologize, guys. All right, let's get on with the show. So are we technically in the Van Oort cloud? I'm sure. It's like cloud 9, right there. All right, guys. Thank you guys so much for being here. I do appreciate it. Please like, share, subscribe, send this out, do all those little things that they tell you to do. But tag somebody in the comments if you think this is going to be a great show for them. We're going to be talking about, pull out my notes because I actually took notes for this one. We're going to be talking about rapid, SPYDR, mud check automation, methane and abandonment wells, geothermal, Eavor, and talent development with Dr. Eric Van Oort. He told me to call him Eric, but sorry, I want to be able to be proper and respectful to professors. So I did go to school, so I didn't go to that school. I wasn't good enough to get into UT. So anyways, all right, guys. Live from the monkey board is definitely a possibility. Okay, so let's do this. We've got the how it's done preview here. After that, we'll be back with our guest of the day. And before I forget, nominate somebody you guys think we should do the minute with. Who do you think is the next person? So we had Keith. Prior to Keith, oh my gosh, Fahim. Sorry, prior to Keith, we had Fahim. So who should be the next person to be able to come on the show that we can help out and help do a little bit of promotion for? All right, this is your how it's done intro. If you guys haven't seen it, be sure to check it out. If your company wants to be a part of it, get in touch with me. We're finalizing season 2 right now, so act fast. And then we'll be back with our guest of the day. Thanks, guys. Dr. Oort, thank you so much for being here today. I really do appreciate it.
It's actually Van Oort, but I love that comment about the Oort cloud, because that's a real thing. It's outside of our solar system, and it was named after Jan Oort, who was a famous Dutch astronomer. And when I was in college, people thought I was related to him. I would tell people that he was my grandfather. We are not related at all. My name is Van Oort, and his name was Oort, but people kind of mistook that relationship. So it was kind of funny. I was regarded with respect at the University of Amsterdam because of my relationship with Jan Oort.
Well, I mean, I'm learning something that I didn't anticipate. I thought it was going to be more towards the drilling upstream side, but now there's a cloud outside our solar system, the Oort cloud. All right. So, all right. I guess
one day we will be drilling it for resources.
All right. Well, I guess we're done for today. We learned something. All right. See everybody next week sometime. All right. No. Thank you so much for being here, guys. If you guys have any questions, be sure, please throw them out. The show's not all about just me asking questions. It's also about getting the questions that you guys have and getting them answered. So, want to be able to start off, Dr. Van Oort, and please, can you tell us a little bit about your job and what you're doing there at the University of Texas?
Yeah, for those of you that don't know me, I started my career out with Shell. I worked 20 years for Shell in a number of different jobs, starting out as a research scientist and ending up as one of the drilling managers in the US before I came to UT. So in 2012, after 20 years with Shell, I was offered this wonderful opportunity with UT to become a professor there. And I've been lucky enough to find some great collaborators at UT, some fantastic people to work with. And together we've built a couple of things. I'm the director of a consortium, industry consortium called RAPID, which stands for Rig Automation and Performance Improvement in Drilling, which deals with automation and data analytics, so big data. I've also started a consortium around well integrity and plug-in and abandonment, which is going to be a really big problem for our industry going forward. Already is a big problem. And that consortium is called CODA, for well construction, decommissioning, and abandonment. And CODA is also the last piece of music, so it's kind of prosaic to call the end of well life kind of the coda, right?
I was thinking of the racetrack, but that's just me. I'm a motorsports fan, so I'm getting everything wrong today.
And then more recently, I've become involved with GEO, which is the Geothermal Entrepreneurship Organization at UT, and the person that was the main thrust behind that, Jamie Baird, got me really involved with geothermal, especially geothermal drilling.
And Jamie's been on the show before, so
yeah,
she's done some amazing stuff on the geothermal side. So we're glad to be able to hear that. All right, so
Jamie is a force of nature. Jamie is the one who's completely revitalized this interest in geothermal almost single-handedly. Certainly from attracting attention from the oil and gas perspective. Yeah.
Well, let's jump into that. We can kind of go in reverse order of what we had here in my notes. So tell us a little bit about your thoughts on geothermal and where you see it right now and where you think that's going in the future.
Well, that's a very good question and a very difficult question to answer.
Just like any good professor, you got to ask tough questions, right?
Exactly. Stump the professor. That's the role of every good student, right? No, geothermal is and I'm still learning a lot about it. I have no long-term background into geothermal. I mean, my background in oil and gas is drilling high-pressure, high-temperature wells, really deep wells with Shell, for instance. But it looks extremely exciting what can be done in the future with geothermal. It can deliver, if we do it the right way, it can deliver kind of scalable, dispatchable baseload energy, right? Energy that is available on demand, that doesn't require storage. It will work all the time. The Earth's heat is available all the time. For it to work, we will probably have to start drilling deeper if you want to get away from the kind of the traditional hot spots around the Earth, around volcanoes and other kind of plate boundaries and so on. Iceland is a pretty unique place, but you don't have Iceland everywhere. If we want to go to higher temperatures, we need to drill deeper. And if you drill deeper, especially into harder rocks, you need to really get down to drilling very efficiently and getting the drilling costs down. Everything these days revolves, of course, around profitability, economic viability. Drilling and well construction is 50 to 70% of the cost of a geothermal project. So we need to tackle that cost, right? We need to get that cost down. And that's primarily what I'm interested in and what I'm working on, to find ways to drill more efficiently, deeper in harder rocks. And that's certainly going to be a very exciting future. But that needs to happen, right? We need to be able to drill deeper and to drill faster and so on for it to become bigger. I think previous guests on your show have reflected on geothermal, and geothermal is still a small industry, right? With the number of wells on an annual basis kind of dwarfed by what we drill in oil and gas. So if you want that to expand, right, you need to make it more economically viable and more attractive for more players to enter into the market.
So is it kind of like a chicken and the egg thing, where to be able to get costs down, you've got to have more service companies interested in developing technology for it, but for companies to get in putting investment in that direction, there's got to be enough work to be able to sustain that investment. Do you think, is there a way to be able to break that cycle, or is just the level of interest right now that's being shined on that portion of the industry and the climate change and green movement that's taking place? I think we can all agree within our everyday lives that you keep hearing in the media and stuff like that. Do you think that's enough to be able to kind of break that cycle?
Yeah, well, there's some good news in this regard, right? I talked to my friends in industry with companies like NOV and Baker Hughes, and they have developed some amazing technology, right, that can drill much better at higher temperatures. drill bits that can handle 300 degrees centigrade, BHAs, MW, LW equipment that can handle much higher temperatures and so on. These companies right now are all kind of struggling because of the downturn. Right, 2015 was difficult, and then COVID hit, and so these companies are all kind of strapped for cash right now, and they're not going to be developing technology. They're not going to be building equipment if there's no market for it. So you have to work on the market side, right? You have to kind of create some demand, and that will require some big institutional donors, like the US government, like the EU, maybe like philanthropy and big organizations like the Gates Foundation, and so on, to step in, to kind of put some money into this, to start developing that market and to start developing that pool. If you expect it to happen organically, for these companies to put in a lot of money right now to develop the technology, it's probably not going to happen, right? There's no justification for it. There's no CEO that would sign off on it if there is no road to kind of a market and to profitability.
Wow. So you said the Gates Foundation, is that a philanthropy organization that's actually looking at potentially investing into geothermal? Yeah,
they are, of course, interested in. So these big organizations are, and at UT we've talked to several of them. They are interested, of course, in alternative energy, green energy, and potentially investing in that if there is a compelling case that can be made. Right, and it's, yeah, I'm mentioning the Gates Foundation, but it's Larry Allison, who actually runs a geothermal facility, I believe, on Hawaii. Right, there are other organizations, of course, that might be tempted, might be interested.
So obviously, you're part of the group called Eavor, or the Eavor Loop. Everloop. Gosh, I even asked you to make sure I got that right. I still did it wrong. Everloop. Can you explain a little bit about that technology and what's unique to it?
Yeah, the main two technologies, I mean, there are a number of different geothermal well designs, right? But if you look at the main front runners right now for being taken further in the future and potentially generating a lot of energy, a lot of electricity, it's EGS, engineered geothermal systems, which are well designs where you pump heat exchanging fluid through fractures, either a natural fracture network or an induced fracture network through hydraulic fracturing, or a closed loop system. And for closed loop system, again, there are different designs, but the easiest to picture it is a U-shaped loop, where you pump in cold fluid from one end, and you get heat exchange along the deep loop, and you produce warm fluid, hot fluid out on the other hand that you could generate electricity from, for instance, or use for direct heating. And so Eavor is, I'm a technical advisor to Eavor, helping them to kind of mature that closed loop concept, which I think is very viable in the future. Most of the attention has gone out to kind of EGS. Most of the funding right now from the Department of Energy is going to EGS. But we believe that closed loop is a viable alternative and actually addresses some of the downsides that we might see with EGS. And Eavor is, it's a Canadian-based company, but is now branching out and is starting to, for instance, do projects in my home country, the Netherlands, and in Germany.
Wow. And so with that technology, so one of the things it's kind of been interesting is like if the drilling portion of it is the largest cost, but once that's done, if you have a closed loop system, then essentially once it starts to produce heat, then essentially all you have to do is just to be able to optimize your surface facilities. And so one of these facilities could be, I mean, correct me if I'm wrong, these facilities could be in place for an extended number of years. Like, I mean, obviously, like you said, the heat from the earth is not going away. So like, it's not going to have kind of like the the reservoir engineering's like, decay curve that you would have with a like a normal oil and gas well. So are these just like essentially just a flat line of energy, and then maybe even going up as the topside energy transfer gets better?
It's a little bit more complicated than that.
Obviously, because I have no idea what I'm talking about. I'm just making guesses.
You're absolutely right. If you put a geothermal well together correctly, and you manage it properly, then it could potentially live for a very long time, right? It could outlive an oil and gas well, especially ones that are on fast decline curves for many, many years. You, of course, you will deplete the heat around the well, right? And it'll you have to, of course, understand how that heat evolution is going to go over time, and whether what type of heat transfer you have, if it's conduction or convection. With conduction, you will see a reduction in, if it's only conduction, right? You'll see a reduction in the heat output from the well over time for sure. The more you can kind of stimulate and bring in convection, the better it's going to be. So but yeah, you're absolutely right. I mean, if you, which is also kind of an interesting challenge from my perspective, if we put these wells together well, then they could potentially live for a long time and be productive.
So higher coefficient of H, the better. This is reminding me of my old heat transfer class from college. So wow, getting all the old college vibes. So let's get a couple of questions that have already come in. So I want to be able to start addressing these now before we just completely miss them all together. So we've got a couple. Does percussion air drilling play? I have it up here on the screen. I can do this. Why can't I? Got to get myself squared away here. Does percussion air drilling play a role in geothermal drilling at present? Thanks, Wayne, for the question.
Well, percussion air drilling you can do as long as you are not intersecting the water table, right? And as soon as you get water influx into the well, you need to go to mist or foam, and eventually you will need to mud up. But percussion drilling with mud is definitely a viable way to go, and may actually be one of the real ways of increasing rate of penetration in hard rocks, right? So drilling with percussion hammers, percussion rotary drilling is something that is definitely being looked at very carefully right now. And you could potentially get much higher rates of penetrations in granites and basalts that way.
Well, speaking of drilling techniques, Leaked User asks, are there some companies that are experimenting with plasma bits for hard rock geothermal? Do you see this as a viable technology?
I think it's a very interesting technology, and there are a number of interesting technologies that have been supported by the US government over the years, by DOE and ARPA-E. And they include plasma drilling, but also drilling with lasers and drilling with millimeter waves, and the development of spark bits. And I as a technologist, I support those developments, right? But I have an old book here. It's by the very famous engineer Bill Maurer. The ones on the stream who are a little bit older may know Bill. He actually still lives here in Austin, and it says novel drilling techniques, right? And he wrote this in the 1960s. And guess what? It mentions drilling with plasma and with lasers and with microwaves, right? So these technologies have been around for a long, long time. And although there are some new developments, it'll take some time to mature. And I think the majority of them will not mature within the next decade or so. On the other hand, we have technologies right now that we can make work better, more efficiently right now, including hammer drilling, including making PDCs work in drilling harder rocks. There are some really exciting new developments going on in PDCs with respect to diamond manufacturing, for instance. There's not too much I can say about that, but you'll see a lot more in that space. Hybrid bits, right? Chimera bits, for instance, those are very good at drilling very hard interbedded formations. All of that we can optimize. A former guest, and I think a beloved guest with your audience, is Fred Dupriest, right? And Fred has started this whole revolution of drilling optimization by addressing drilling limiters. And that is a way, for instance, to get also efficiencies for these conventional drilling technologies into geothermal drilling, right? By rigorously addressing drilling limiters, particularly vibrations, when drilling harder rocks, and just getting, for instance, PDCs and hybrids to drill effectively in very hard stuff.
All right, so we got another question here. This one's from Mark Willerth, who's actually the membership director for the ISCWSA. We just had our meetings the past 2 days. I didn't get to attend because I was going to sign up late, and it was $200. Sorry, guys, wasn't there. You mentioned the need to drill deeper and faster. Is faster the true requirement, or is it just a proxy for cheaper? Could automation provide a pathway to lower cost, slower drilling?
Well, what was it?
Mark's asking the tough questions.
Yeah, that's a tough question. I mean, the joke at Shell was always faster, cheaper, good. Pick two, right? No, we are indeed looking for drilling faster in hard rock. It has to happen, but of course it has to happen in a controlled way. Something that I've seen, for instance, we've done a whole. This will be of interest to you, David. At Rapid, we did a whole project with some directional drilling experts, by the way, on looking at wellbore quality, for instance, right? Looking at wellbore tortuosity, because we found that some people that focus strictly only on drilling fast were actually drilling very tortuous, very poor quality wellbores. That led to problems running casing and problems getting good zonal isolation with cementing, problems with production due to near wellbore fracture realignment, and early wear on submersible pumps, right, when they were set in kind of crooked, high dogleg parts of the well. So, yeah, you want to drill faster, but you want to control the process, right? You want to do that. And automation, I think, is the key. Automation actually in a very advanced level. I mean, we're currently at the stage where automation is at the level of kind of human advisory systems. But for instance, when it comes to drilling automation in geothermal, I think ultimately we'll go to full automation with full closed loop systems where the machine basically makes the decision. For instance, for drilling efficiency optimization, you will have to really look at the high-speed dynamics carefully with the right telemetry system. You and I have talked, for instance, about wired pipe, right, in preparation for this talk, where you can measure actually what is happening at the bit at high speed and get that data to the service and act upon it. And you will have to do that, for instance, if you want to keep your bits intact, right? If you want to keep the bits living for a longer time and drilling faster and deeper. And I think that's, for instance, technology that needs to happen both in oil and gas as well as in geothermal. In geothermal especially, we cannot allow bits and BHAs to be damaged. So you need to be very quick when it comes to diagnosing adverse drilling conditions.
So, other question we've got here from Spencer. Thank you for the response, by the way. U-shaped designs are extremely expensive wellbore intersections, running casing, sealing casing, etc. Given the energy payouts for geothermal, how do you plan to offset those extreme costs?
Well, I gave U-shaped designs only as an example of a closed loop system, right? You also have designs where you have pipe in pipe, where you pump down the annulus and bring the hot fluid back from the subsurface through an inner bore, maybe vacuum insulated tubing and so on. Yeah, I mean, right now, as I said, as I indicated, the key is to reduce the cost of these right now still very expensive well designs, and that will need to happen in order to attract more investment and more attention to this. But do understand that, I mean, we've gone through this with other alternative energy sources as well. We've gone through this with solar and wind. It took a while before those became economically viable. 20 years ago, I mean, the cost of solar cells was astronomical, right? And they've worked very hard with a lot of government funding to get the cost down over time. And the cost comparison actually with, for instance, between geothermal and something like solar is not I think a fair one in a way. Usually they do it on kind of a levelized cost of energy, right? Saying that for it to be viable, it needs to be kind of 2 to 3 cents per kilowatt, I believe. But that looks at the cost, for instance, of solar without storage, right? And of course, with solar, you need storage, right? Solar doesn't provide base load. So you can generate energy when the sun shines, but then you have to store it somewhere. So I think geothermal is also kind of held to a higher standard in comparison with other alternative energy sources right now. But apart from that, right, we need to bring the cost down, and that'll be the focus of my team and myself in the future.
We've got another one here for the geothermal. What is the minimum bottom hole static temperature, BHST, that is needed to consider developing for geothermal use? And now, if I got that acronym wrong, please just correct me, guys. I have no problem being wrong, especially here on my show.
You are not wrong. And you will soon be a YouTube millionaire with all that.
I've made it a whopping, I think, $3.35 over the last week and a half. So yeah, and if anybody is watching on YouTube and you do like what you're seeing, you can do the little super chat where you just click a little button and it'll be like 99 cents or something, and your thing will pop up here on the side of the screen. You don't have to, but if you want to, feel free.
Well, to answer the question, and yes, you're right. It's BHST is bottom hole static temperature. It depends a little bit on what kind of geothermal application you're interested in, right? You can actually at fairly low temperatures use it for direct usage for heating. For instance, that's what they're very interested in. For instance, in Western Europe right now, in places like the Netherlands and Germany, just to use it for area heating, for instance. And you don't need very high temperatures for that. If you really think about generating electricity and putting hot fluid into a turbine, or using that with a binary plant, well, then you want to have temperatures at least above 150 degrees centigrade, and preferably higher than that, right? For those deep designs that I'm looking at, I'm targeting something above 200 to 350 degrees centigrade. So yeah, it gets pretty hot then.
Not many MWD tools on the market that can do that right now.
No, and MWD tools typically have a limit at around 175, I believe. But again, there are new developments there. There are new sensor developments, new transistor developments, new cooling techniques that are being addressed.
Excellent. And so, like you were saying there, as far as direct heat applications, I think I read somewhere that they can drill wells that are fairly shallow. I'm not going to give it a specific depth to it, but fairly shallow, and then they can use that to be able to heat almost like an entire block or a small neighborhood with that application.
Yeah, absolutely. Yeah, and that's a very good, very viable application of geothermal.
Excellent. Well, I know. So we've talked a lot about geothermal, and guys, I'm not ignoring your questions or everything. I just know that we've got so much to be able to cover here as well. So one of the other things I want to be able to jump into is some of the automation stuff that you're doing. You said you've been working with the industry consortium Rapid, and as well as your company SPYDR. You pick which one you want to talk about first, and we'll give it a shot.
Yeah, let's talk about Rapid first, and then we'll talk about SPYDR.
Excellent. So what is the industry consortium there that you guys there at UT are doing with some of the big players here in the oil and gas industry?
I've got a slide that I can show you. Can I pull that up?
Yes. Love to.
I came prepared. Let me see.
I can't say that I did. Hey, you guys out there that are watching, thank you guys for being here. We do appreciate it. Please tag a friend in the comment section. I'll add this to the. There we go.
Well, let me see if I can put it in presentation mode. Can you see this?
We see the layout, so I can see about 9 slides right now.
See it now?
Still the same.
Okay, then I need to share something else.
No worries.
I'm sorry.
No, we got plenty of time. If anybody's watching the show and they're in a hurry, probably not the good idea to be doing on Fridays. And just for everybody who knows, doesn't know, if you miss what we cover here, or if you can't watch live, or if you miss a part or whatever, you can always go back over to YouTube and watch them there. That's how I become a millionaire, right? That's why you guys watching stuff on YouTube. Not really. All right. So it's starting to come up. I can still see the 9 slides.
You still see the 9 slides. That is not. Well. Let me just share my entire screen then.
Can do that too. All right, so we have gotten, I can go back to some of the people that were saying good morning. Might have missed a couple of, oh, there we are.
What about this?
Let's see here. Add to strip. There we go. UT rapid focus areas. You are sharing your entire screen.
Good. We got there in the end. It's a bit embarrassing for a technology professor to kind of struggle with technology, right? But
no.
But so what I do with Rapid, and Rapid, by the way, is a true consortium. I have some really good collaborators at UT on this. I work with a number of other professors and senior scientists to do this. It's always better if you can do it together with somebody. If you can find a collaborator or collaborators. You can be the smartest person in the world, but it's always going to be better if you find other smart people to work with. And that's what we do with Rapid. So it has kind of 4 pillars. One is sensors and automation control systems. The other one is modeling and simulation, what we call digital twinning. Then we got a lot of data on which we do big data analytics. And then we have a separate group that does intelligent mechanization and robotics. The group there was the traditional group sponsoring Rapid. It has shrunken a little bit in the downturn. We've lost some of the major oil companies. Some of the smaller companies have stayed, whereas some of the majors have dropped off, hopefully only temporarily because of budget cuts. But you see Eavor in there as well. Eavor is a member of Rapid. And so that's what we work on. And one of the things, of course, that we work on right now in Rapid is this energy transition, right? Starting to look at geothermal in particular, and telling oil and gas companies that they actually have subject matter expertise in this area, and that is kind of remarkable that they've entered into solar and wind and biofuels and so on, but not into geothermal. But that's now starting, so we see good interest and some forays of oil and gas companies getting into geothermal. But yeah, so that's what Rapid does. So, and we can talk about specific topics of interest to people.
So, what have been some of the big accomplishments thus far that y'all have achieved with the Rapid group?
Well, the biggest things that we work on, the most successful ones are actually the data analytics studies, right? So when I came to UT in 2012, I had been running the real-time operating centers at Shell, and also the DART centers, the remote directional drilling centers that were created for remote directional drilling and geosteering. And I'd really become convinced that data is money, right? With data analytics, you can create tremendous savings. So we've done over the years, we've done these data studies for companies. We have phenomenal access to company data. It took Pradeep Ashok, my main collaborator, and myself 2 years to convince companies to actually start sharing data with us. Took us a long time. Companies were keeping it very close to the chest. But then once we started doing that and looking at drilling limiters, looking at the root causes of downhole failures, we've done studies related to pull pressure, frac rating prediction. We're doing one right now, a little bit out of our field, looking at the effects of frac hits, effect of child stimulation on parent wells. And the learnings of that have all been implemented by operators out in the field, and that has worked out extremely well. And then we've built software that companies are using. We're building sensors where we see some uptake now as well. So we're working currently on a project that I'm very excited about, which is bit forensics, together with the IADC. In fact, Rapid kind of supports IADC in coming up with new ways of doing bit dull grading by taking images of bits, analyzing that with a pattern recognition algorithm, visual analysis, and then automatically classifying the damage, doing an automated dull grade, right, very consistently, and then connecting that information about what caused the bit to damage back to the original data to do real forensics in finding out what caused bit damage and bit death, if you want to be a little bit dramatic, right? So that's a phenomenally fun project to work on, and if you're successful in that area, it has immediate application.
Wow, it's interesting. Not only is it automating the grading process, but then being able to correlate that back to what's taking place during the drilling process. So what kind of data are y'all looking at? Is it downhole recorded data, or is it surface EDR data, or is it a combination of the two to be able to figure out what was the as you say, the mode of death for the bit?
Yeah, I'm going to try my hand again at sharing something with you. Let me see if it works.
No worries. And Brian, we see your question. I'll get to that one just next. Guys, if y'all do have any questions that y'all want to ask about the stuff with SPYDR Rapid, go ahead and throw those out there. And we'll also be talking about methane abandonment next, and then probably end up with talent development towards the end.
Do you see my screen?
Yes, sir, I do. Got it up there. Oh, I got to take that thing off.
Yeah, so you see a drill bit, right, with some damage to the cutters, probably from vibration. Might be lateral vibrations, might be stick slip vibrations. By going back into the data, we can use surface data, but we preferably would like to use downhole data if we have downhole accelerometer data or gyro data, for instance. And then what we do is we take images of that bit on surface. You put that into kind of a machine learning system that does image analysis and identifies the cutters from the images, and then starts kind of classifying the damage, and does that completely automatically, right, based on the training data sets that you have given it. And in this case, you can then completely do a very accurate analysis of the type of damage. Is it damage to the face of the cutters or to the shoulders or whatever? and then connect that later on to, of course, what was the root cause of that damage? What caused that bit to fail in a particular mode? So that is an extremely exciting project. And as I said, we are working together with that on with the IADC committee, headed by Paul Pastusak. And that, as I said, if you come up with something good, then that has an immediate application, something that operators can use immediately. So that is what we call applied basic research, right? Research not for the sake of doing research, but research that actually has an application for operators out in the field.
Awesome. So on the training data sets, are you guys taking pictures of newly manufactured like green bits before they go in whole, so that there is essentially a direct comparison, like a before and after? Or is there the ability, because I know some companies out there are even talking about using the three-dimensional models and stuff from when the bit was actually being designed?
Yeah, you can use all that information. You can use new bits. You can use the CAD drawings from bits. We don't necessarily need to have 3D models. We can do it from 2D models. In fact, what we've done is we're in the process of creating an app, right, where you could just at the rig site photograph your bit, and then the app kind of runs on it and tells you what the damage is, right? And if it has access to the data, then it can connect that with the original cause of what caused the damage of the bit.
Wow. No more arguing about bit dull grades at the rig site anymore.
Yeah. And of course, ultimately what you want to use, and here we come back to kind of the geothermal side again, right? If you find out that certain patterns in your data were indicating certain vibrations, for instance, stick-slip vibrations or lateral vibrations or bit bounce or so on, and you can connect that with a certain damage or wear pattern on the bit, then of course next time you can use that information, that if you see that pattern in the data again, you can start taking corrective action, right? And keeping your bit healthy and drilling longer sections and at higher rates of penetration.
Well, somebody that's a part of this project, Dustin, said, we'll still be arguing. So Dustin, thanks for watching. All right, so we did have another question came in from Brian. Brian asked, what is the status of automated drill-a-stand?
Well, that is not a good question for me. That is a question that you should give to the DSATS group of SPEs, the Drilling Systems Automation Technical Section, because they've been really involved with kind of drilling a stand in an automated way, right? And I've kind of tongue-in-cheek also been criticizing them for that, because that's kind of been their singular focus, right? Whereas we have all these other things to automate as well, right? We have to automate tripping and well control and drilling fluids, right? That's what I've been doing with SPYDR, and cementing, the myriads of things, right? Part of the well construction process that also needs attention, whereas DSATs have kind of been focusing singularly on automating the drilling of a stand. So I would actually encourage you, David, to get somebody from DSATs in here. Mark Anderson, he was on the show, right? And he was the chairman of DSATs for a while. I might still be the chairman of DSATs.
Mark's been on. John DeWart's been on. Fred Florence has been on. David Reed's been on. I'm one of the subcommittee chairs. So,
good.
There's a couple.
And then you see how disconnected I am, right?
I'm working on my one part, and I'm very slow at it. So I won't throw myself too much under the bus there. So one of the things you mentioned there within regards to automation is your SPYDR project. So give us a little background on what that is.
Yeah, so when I came to UT in 2012, I mean, when I was hired by Shell, and I I have to admit, I didn't want to work for Shell. I was planning on an academic career, and then I was offered the job at I wanted to work for Shell for the downstream side, and then they say, no, we'll hire you, but you need to take a first job in E&P. And I remember asking, what is E&P? I didn't know. and then they said, well, we need a physical chemist like yourself to work on mud. And then they showed me a mud lab, which was dirty and it reeked and it was horrible. And I was going, man, I've got a wonderful, wonderful career behind me, right? Wonderful future behind me if I go and do this. It took me 3 weeks to actually accept the offer by Shell. But then I started doing drilling fluids. They gave me lots of money to do research, and I had a lot of fun. And in hindsight, it was the best decision that I could ever make. And I really had. I'm really very thankful to Shell for the opportunities that they have given me. What was I talking about? I've lost myself. What
SPYDR.
was the question?
We're going towards SPYDR.
So I'm a drilling fluid guy by background, right? That's what most people know me for in the industry. So when I came to UT, I was really interested in what I at that time called a one-button mud check, where you could just press a button and the mud check would just come rolling out, fully automated, right, without doing the manual labor involved. And I've got some slides for you on this. If you
bring them
if
up,
you want to indulge me again. Let me see. Give me
anything for you, sir.
Because the API mud check has been extremely successful, right? But the protocols, the measurement protocols are very old, and I want to show you how old they are. So let me see if I can get. Give me 1 second. Nearly there.
So Mark says currently currently mud checks are a 2-button process. Copy and paste the last one.
Is this Mark Anderson?
Mark Willerth from he's over at HEP Technologies.
Yeah. So this is the typical kit. Can you see my screen? Yeah.
Yes, sir. We got it up.
So this is the typical kit that a mud engineer uses, right? And most of these tests are from the 1950s and 60s, but some of them actually date back to the 1930s, right? The Marsh funnel that you see there on the left, Marsh funnel was introduced by Dr. Marsh in 1931. And just to give you an example of how old that is, right? If you wanted to buy a new car and you wanted a Tesla, right? And I said, no, you can't have a Tesla. You need a Ford rumble seat roadster, right? That is the car you're going to get, because that was what was available in 1930, right? Or you want to have some Netflix for streaming, but we've just invented this newfangled thing called radio, and I'll give you this wonderful Bakelite radio, and that's what you're going to do radio and chill, right? And and no penicillin or vaccines, right, for your minor infection, but just called old-fashioned 1930s death, right? Because I believe in 1929, penicillin was invented, but the production wasn't large scale until the Second World War. So, I mean, we find this completely unacceptable, right? But we've somehow accepted when it comes to a mud check, right? Using the Marsh funnel. That is technology that is now almost a century old. And then you have to ask yourself, how do you go about dishwashing, right? And if you look at dishwashing, what you could consider is just to do the task that humans do, right? So build a robot that washes dishes. Of course, this is not a great way to go about it. What you're going to build is a parallel process or a parallel dishwasher, right? And that's the one we have in all of our in our kitchens, of course. What you could invent, of course, is a robot to put dishes into the dishwasher. When you go about automation, what you shouldn't do is build dishwashing robots. That's basically the message here. Don't do what humans do. But that's exactly what people have done. And this is my favorite slide to make fun of DSATs a little bit. This is a publication by DSATs. And I hope that you see in the red square that somebody has automated the marsh funnel, right? And that's what I call a dishwashing robot, right? That's basically trying to automate what a human is doing, and that's something that you shouldn't do. So what we've done with SPYDR is we've looked at the old equipment, come up with new sensors, new ways of measuring things, and then really combining that with machine learning and artificial AI, and then building that into a skid that we have out in the field right now that does automated measurements. So this is the skid. It's currently operating out in the field in the Permian with Pioneer, where it's measuring in a fully automated way rheology parameters, friction factors, Reynolds numbers, density, and oil-water ratio. And then there are other parameters that you could add to this as well. But now we have, for about 95%, a fully automated mud check. So that is what I'm doing with SPYDR right now.
Wow. Somebody said slide number 153. How long is that presentation?
Well, I take you seriously, David. I mean, you're becoming a very well-known guy, and I wanted to be prepared for this this meeting. I know that my reputation could be at play here.
Well, on the automation talks and building the dishwashing robot, a friend of mine had once said, you know, it's like if you're trying to automate how to be able to tie shoes, you can either create a robot that ties the shoes, or you can create a robot that just folds over Velcro. And both of them achieve the same thing, but one's a little bit more simple than the other. And so it's interesting to be able to see the analogy the way you put it there. It's, you don't want to create the robot to wash dishes. You have the dishwasher that does that, and then the one that can load and unload.
You need to make a functional look to what the machine needs to do, right? And then find the best way with modern technology to arrive at that. There's a great rig builder, drilling equipment builder in the Netherlands called Huisman. And they build equipment that looks completely different from everybody else's. And they are rigorous about looking at what does the machine need to do, and then how can we do that most efficiently, most logically. And typically what you come up with is something that is different from what a rig used to look like 100, 150 years ago, right? 120 years ago. We still use kind of old designs, and if you get somebody to take a fresh look at it, you come up with something completely different. That is actually a lot more efficient and a lot smarter in doing things. And I don't know if you've ever seen the Huisman's kind of offshore rig designs and even onshore rig designs, but they are extremely clever in the way they put them together.
I haven't been up close and personal, so I've seen some of the pictures, but because they are so different, it's kind of hard to understand exactly what's doing what. It's definitely one of the companies I would love to be able to get a tour of, facility or offshore installations at some point in time. So if anybody there's watching, feel free, give me a shout. I'll go get my Hewitt stuff done, and then we'll go out to the rig. So one of the things we talked about before was the fact that with SPYDR, you took that company out there on your own when initially you said you were looking for industry partners. Why wouldn't somebody want to partner up with you on this project?
Yeah, I've sometimes failed horribly. This is a good thing for your younger audience to know, right? That even if people people sometimes are very successful. They've also failed horribly, and I've failed horribly a lot of times. It's part of the process, by the way, and you shouldn't get discouraged by it. It's not a bad reflection on you. Losing your job is not a negative reflection on you, right? It's a set of circumstances, and you just keep at it. And I'm happy to see, David, that you are helping people to get employed again. That's a great thing to do. When I, for instance, one of the reasons why I joined UT was I wanted to work on cementing and zonal isolation in the aftermath of Macondo. That was actually part of my motivation to come to UT. And I thought, this is going to be a huge success, right? Deep water operators are going to throw money at me to solve this cementing problem for them. So I built a nice cementing lab, and I got nice equipment and new ideas on how to solve this and address this. And crickets, right? Nobody interested. Absolutely not. I couldn't get money out of anybody. Just got a complete miscalculation on my part. And I had the same expectation actually for the mud automation. I thought, well, I mean, people must be knocking on my door all the time, right? I'm gonna have my pick of who I want to work with. Again, everybody said, we like this. This is great. We need this. Man, MPD needs this really bad, right? We need direct input of rheological parameters into MPD control systems. Nobody available to commercialize it with, right? And I tried for a period of 5 years, to the point where I said, well, there's apparently no other alternative. I need to do this myself. So I have a great friend in, well, first of all, I have great students that have worked with me on this. And one of them is actually listening. He's just graduated, is Serjan Gul, who worked with me at UT and is now going to work for Pioneer. Fantastic student. And now Dr. Gul, right? He's now my equivalent. So fantastic students. This is the fun part of my job. I get to hang around with really smart young people all the time. That is the fun part of being a professor. But I have a really good friend in Houston called Munir Aldin. He runs Medrock Laboratories. If you're ever in Houston, go to Highway 6 and go visit Medrock. And they're master equipment instrumentation builders. So I went to Munir and I said, Munir, can we just do it ourselves? Can we just build it ourselves? And he took a risk, and so now I'm doing this together with Medrock. So SPYDR is doing this with Medrock, and we're very proud of the achievement. Hopefully it'll pick up and find a market.
Well, I definitely think the plug here on the Eavor Locksmith show is all you need, and by this time next year they'll be on every rig. Hopefully. Yeah. All right. So, all right. Sorry, guys. I'm just checking the comment section. I keep doing this. I keep looking down here. The screen print's just too small. I either need better glasses to be able to do that or something different. But, all right. So I'm going to switch gears when we go on to the next topic. So one of the other things, and you've been talking about, being able to work with a lot of the students and stuff there at University of Texas, and like you just said, Dr. Gul, who's now over at Pioneer. One of the things we talked about is you said it's been your mission to help develop talent. What has been your kind of philosophy in doing that, and to be able to help these students transition from being in academics to being a professional?
Oh, thank you for that question. That's a wonderful question. First of all, for all of the people on the stream that are kind of later in career, I'm now later in career, although I don't plan to retire. I have too much fun. But
that's the spirit.
Yeah, no, I mean, just life is short, right? Just do what makes you happy and have fun. And I'm going to do this as long as I can pass the red face test in the mirror in the morning, that I'm still relevant, right? But yeah, I'm not planning on retiring anytime soon. I'm just going to keep doing it as long as I'm making a positive contribution. But again, for those late career individuals on the stream, consider teaching and consider mentoring. It's one of the most satisfying things that you will ever experience. If you can transfer your knowledge to a younger generation, and you'll be amazed how smart these kids are. I'm teaching a advanced well construction class right now with a mix of undergraduate and graduate students, and these kids are so amazingly clever, right? I had them write a midterm paper on geothermal well construction, and you should see the submissions, right? They're excellent, right? Something that you could just publish as an SPE paper. That is so tremendously rewarding. And for me, it's an opportunity, of course, to share my industry experience. I'm a little bit of a different professor than other professors. I'm always kind of a professor of practice, sharing my industry experience, because a lot of professors that you find in academic institutions have never spent time in industry. And frankly, don't take this the wrong way. I know that a lot of people might be offended by this, but they don't do a good job in actually preparing these kids for industry, right? Companies hire them and then they need to retrain them all together, because guess what? The job is not about solving partial differential equations, right? I knew how to do them as well when I joined Shell, and I think I've done one during my period at Shell, right? That's not what it's about. So we need to do a better job, I think, about preparing our students for a life in industry. And I as I said, I came prepared, so I want to show you something. I used to teach a little bit of a class called 12 Recommendations for a Successful Career in Industry. You want to see that?
Yes, sir. We would love to see that.
Okay, good. Let me show you.
And somebody says, anybody else notice that Eric sounds a wee bit like Sean Connery?
I've had that heard before. It's either Sean Connery or Arnold Schwarzenegger. It's Sean Connery because I roll my R's. So people always think that I'm Scottish instead of Dutch. There you go.
So Ian says, always, as always, inspirational, a man of useful learning.
Yeah, this is the great thing about brain plasticity, by the way, right? Your body gets old, you start to look really haggard when you look in the mirror, but your brain can stay young, right? I know some guys that are in their 70s and they're still writing excellent papers, filing patents, and so on. It's just up to you if you allow your brain to go old. You can stay young while the rest of your body kind of deteriorates. But do you see my screen here?
So real quick, we've got somebody who says, Dr. Van Oort is the best professor I had while at UT, and it wasn't close.
Well, that's very nice to hear. That's why you're doing it, right? For that kind of a response. Yes. That is very rewarding. Yeah. So here are my 12 recommendations for being successful in the oil and gas industry, kind of things that I've learned and that I teach my students, right? One of them, the first one is avoid boring people. Boring people are not nice, so just avoid. No, that's not what I mean. I mean just avoid boring other people, right? And that is learn to write well and learn to speak well. And that is extremely important. If you look at the CEOs of companies, some of them are actually not the smartest tools in the shed, I have to say, but they all know how to speak and write well. They know how to present themselves well, even though what comes out of their mouth is sometimes complete nonsense. So you can learn this, right? Nobody's born a great speaker or a great writer. It's a tool to use. You should work and with good people. The number one reason why people actually leave their jobs is because they're working for bad bosses or bad professors in a toxic work environment. So try to find good people to work with, and you have some control over that yourself. Invest in yourself, and don't go for the money immediately. That'll come later. Build your brand, like Vidor Locksmith, right? See yourself as a brand that you're building over time. Don't just work for money. You'll make a lot of money if you're good at doing something. So become good at doing something, and then people will be the path to your door. You need to keep an open mind and admit when you're wrong if you're wrong, and be very open and transparent about it. Make lots of contacts and lots of friends. You will find, and you know this, David, especially in certain domains, right? Our industry is very small, and you keep running into the same people time and time again, and so you want to make friends, not enemies, and work with people. One thing that I would encourage, especially young students, to do is don't let themselves be kind of discouraged by the older generation that says that something cannot be done, that they tried it 20 years ago and it didn't work. That might have been the case, but what you often find is that with modern thinking and modern technology, you can do it now. So follow your own course and be critical. I think this still holds in our industry, right? Your reputation is everything. So be a person of high integrity, something that other people look up to and want to work with. You shouldn't fight change. Change is inevitable. I know it can be uncomfortable. I know that people can be threatened by it. But if you try to fight change, you're going to lose tremendously. So you need to be a champion for it. Work all around the world if you get the chance. In our industry, work in deep water if you get the chance. I've learned more from my years working deep water than at any other time. Just be a good listener and ask lots of questions, and sometimes just shut up, which is a good thing that I've learned, that sometimes I just need to keep my mouth shut and just listen to other people, and then the solutions are already there in what they tell me. And the last thing is really important. Think big and work on big ideas and big projects, right? Like you are now starting to do, for instance, with your VR headset, visiting rigs and so on. I like that. It takes exactly the same amount of energy. Yeah, it takes exactly the same amount of energy whether you think small or you think big. So think big, work on big stuff, like geothermal. And it doesn't matter if you are going to be the world's leading expert on it. As long as you can make a positive contribution, it's going to be worth it. So those are my 12 recommendations to students for a successful career in industry. So.
An excellent list, absolutely excellent list. I think that every student should have to recite that probably at least once a week to be able to kind of drill it into their head as they come out of school and get into the industry. I mean, definitely I look at, where I started at and to where I'm at now, and like how many of those things are so true and accurate. And that obviously I didn't learn them in, the first week or two. It took a long time to be able to, for me to be able to finally get those kinds of things ingrained in my head. And now I see, it is true. Big projects take just the same amount as the small ones. So it's great to be able to see that, and not to be boring. Is I love that one being first. I wish more people, especially at conferences, put a little bit more personality and humor into it. Maybe that's why everybody likes the show so much, right? Everybody keeps telling me we're covering the exact same topics. It's just that there's I guess a little bit different element to it that we're able to do. So a couple of
you make it entertaining, right? And you make it a bit of a show, right? And otherwise it would be extremely boring and people would not be interested in it. Also, there's one other recommendation. This is important. Again, for the younger listeners, is this: you will only in your life have one teacher, only one, and it's you yourself, right? I'm a professional teacher, but I don't teach. I can't make you learn anything. This is not how humans learn, right? You learn by doing yourself. This is the way you train your neural net, right? The kids that follow my classes, they will forget everything that I will have said, right? Only the stuff that they did themselves. like writing a midterm paper, right? Or solving a problem themselves. That is what they retain. So this is an important thing. When it comes to education, you are in the driver's seat, right? You are your own teacher, and you'll have that teacher for a lifetime, right? What we do as educators is we make it interesting for you. Hopefully we're not boring, right? and we lower the bar for you to access the information to teach yourself, right? So we hopefully kind of give you ideas on where to go and grab the information such that you can teach yourself. But that's the way it works. You do it all yourself. You will only have one teacher in your entire lifetime.
Excellent. So we've got a couple of people who said, great advice, excellent recommendations, recommendations. Thank you for sharing this. And then Carlos says, Eric is a great colleague at UT Austin. From having zero presence in the drilling discipline at UT Austin, almost single-handedly, Eric put our department in the big leagues of professional drilling. Kudos to him and his students and research associates. And that's Carlos Torres Verdin.
Yeah,
I'm guessing it's Dr. I'm guessing that's Dr. Carlos.
You would be mistaken. It would be Professor Dr. Carlos Torres Verdin.
Professor.
We're gonna have a bit of respect here, David.
I need to do some more yes sir, no sirs. And then not gonna even try this one, but it says thanks for the advice, Dr. Van Oort.
Yeah, this is Eve Guo. It was my graduate student. I paid her to say that. No, I didn't. But she's actually logging in from China. So
wow.
Yeah. So it must be the middle of the night for her right now.
I was about to say we won't tell anybody that she's. I mean, I don't know if they're allowed to get YouTube over there, so we won't tell anybody that she's past the great firewall.
Yeah.
And Roger says,
but thanks, Carlos. Thanks to Carlos. Carlos is my great friend at UT. Together we are trying to fight the UT bureaucracy. It's not always an easy fight, but he's my brother in arms.
Well, you like you said, you got to work alongside great people. So there's a question that we have here from Eduardo. It says, how do you convince smaller operators to invest in disruptive technologies when cycle times tend to take longer to properly test a technology and ROI may not be great in short term? I would like to be able to just cut out part of this question and answer this one, but then also another part of the question is just like, how do we get more oil and gas operators, even service companies, to just be able to be open to hearing about new technologies or testing out new technologies? I think this is one of the most difficult things in our industry. And this is where I have been able to kind of find a niche in our industry, is being able to help people go from ideas and technology to convincing people to being able to give it a shot, just because I've been through it so many times now that I've done fairly well. But why does it have to be so difficult? What are your thoughts?
Well, I have as you by now have guessed, I have an outspoken opinion on this, and it is actually getting more difficult to convince operators of the value of technology, which is weird because oil and gas is such a technological business, right? And the major step changes in technology have built whole businesses, right? Unconventionals wouldn't be there without directional and horizontal drilling and hydraulic fracturing, right? Which are major steps forwards in technology. And here's my view on this. And it is my personal view, right? The business schools have played a major coup when it comes to senior management in oil and gas companies. In the old days, well, before the 1990s, when I joined the industry, the leadership of those companies came out of the companies themselves. They came out of the technical ranks, right? The senior leadership team of these companies came from reservoir engineers and geologists that understood the technical side of the business and understood the value of technology. But if you look at the CEOs of these companies right now, they have lost touch with that technical side. They come out of business schools, they're MBAs. They come out of finance, they come out of HR. And they've started to see technology, certainly their own technology development, as an expense. So they have radically eradicated their own in-house technical capability, getting rid of their labs, right? The beautiful lab that I used to work for at Shell in Rijswijk is gone. Well, it's now part of the TU Delft, the technical Delft. But Shell is not operating that lab anymore. And they're also getting rid at an alarming pace of their technical experts, which was not going to serve them well. But that is then the problem as technology providers, right? And how do you engage oil and gas companies still if they're losing that connection to valuing technology the right way and knowing what to do with it and understanding what kind of step change it can bring. I'm not going to say that I have the answer to that. What I will say to you is that the surprising thing is that the most technology adept companies are often the smaller companies. And I want to give a shout out to particularly companies like Hess and Oxy and Apache. They are doing more, probably because they're much flatter organizations, right? And with senior technical folks still advising the leadership. They're doing a lot more in adopting and trialing new technology and seeing what it can bring and seeing what the rewards are going to be than actually some of the major companies. And there is no CEO right now that's going to go back to their investors and is going to say, give me a couple of $100 million, give me a couple of $1 billion to rebuild my technical capability, right? I need to build a lab somewhere. It's not going to happen. And in the end, it's going to work out, I think, very poorly for those companies. And in fact, it's going to be a boon to consultants and to academics like myself, because ultimately they'll have to come to me for answers because they won't have the in-house capability anymore. As I said, there's a very outspoken opinion, but I think that's what's going on right now. And it's extremely worrying. I've been rather dismayed.
If somebody considers that outspoken, they need to take a long look in the mirror. I don't think it's outspoken. I just think it's plain and simple the truth.
Yeah.
I mean, it's very true that they've.
And there's a big downside risk, particularly in our business, right? Our business is such a technical business, right? Where step changes in technology can impact profitability so positively and negatively. A good example, for instance, is dual gradient drilling in deep water. I mean, dual gradient drilling was announced 20 years ago. It still has not happened. But with full dual gradient drilling, you can actually simplify deep water well designs, right? And there's one company, there's one system right now that comes close in achieving full dual gradient drilling, right? But it should have been matured and should have been applied everywhere, and it would have made deep water a lot more profitable than it is today. And I think the reason is it has not, because companies don't understand technology anymore. They don't manage it themselves. They don't develop it themselves anymore. They go and ask Halliburton and Schlumberger and Baker to do it all for them. And it's not a good situation.
And then those big companies just end up buying small companies who've, been the ones to go out there and, take on the entrepreneurial risk, and then they just suck those companies up and then add it to their portfolio. So it's in essence, the smallest of small companies are the ones that are making the biggest changes. It's my belief. That might be my outspoken opinion, but yeah. I mean, I'm a small company that's making changes, so it kind of fits the bill.
Yeah, no, absolutely. The flatter the organization, the more innovative you're going to be, and the bigger the rewards. There is a way of covering your downside risk, right? But then there's a big kind of upward reward that you can get if something works. And we see that mentality particularly with the smaller companies right now, and I applaud them for it. I think it's great.
So what would you say is, potentially a solution to this problem? One of my thoughts has been, and I've told this to several executive level people or people within, some of the operators, to say, look, you're probably going to get a lot of spam with this and a lot of noise with it, but they should at least have some place maybe on their website or some kind of channel to where people with new ideas, new technology can reach out to them and be able to at least just say, hey, look, I'm working on this and here's what I've done thus far. Submit it on their website, and then it filters through whatever noise filter needs to be there. Because like right now, if you know, like you said yourself, if you've got something great, it's hard to be able to get somebody to just even put eyeballs on it, because there's so much competition with what is already commoditized, much less something that's new and may have an element of risk to it. What do you think the industry should do to be able to help itself be able to develop and grow in the future?
Well, no, it's a very valid point that you have. I have a number of views on it. Let me think for a moment. I'm getting a little bit exhausted. I have to admit. But
we didn't mean to wear you down.
Right now, the issue is that, of course, if you want to sell technology to a company right now, you have to find a technology champion, right? You have to find that particular individual, that woman or man, that is willing to believe in you and take your technology forward, right? And it's a very fragile link, right? If you lose that person also, you lose your champion, right? We have to find a better way of doing this. We also have to find a better way of integrating. And there are some hopeful signs, right? What has held back, for instance, let me go back to automation. What has held back automation, first of all, was interoperability, lack of interoperability and lack of standards. What you now, and everybody in the beginning, which was kind of almost more than 10 years ago, right? Everybody was going at their own way, right? Individually, very little collaboration. Now you see, of course, partially driven by the downturn and what has happened with COVID, that companies are a lot more willing to work together, right? Technology providers kind of teaming up. I see some partnerships. Yes, I've seen some partnerships in recent months that I didn't think were possible, right? Where companies are starting to team up and starting to work together. So it's great to see. And that addresses this interoperability and standards part. What also has held back automation in particular was that the value proposition for a while was extremely dicey. It was always clear who was going to be the beneficiary of automation technology. It was going to be the operators, right? They were going to get better wells drilled faster at lower cost. With less rig days, whereas the rig provider, for instance, needed to make the investment in the automation technology that was pushed to them, and now suddenly they were still on a day rate contract, right? Actually making less money per well, and I think that's been a real issue holding back automation. Luckily, right now, what we're seeing is more kind of these true partnerships where there are actually incentivized contracts. Right, where if a drilling contractor drills a well faster, they get part of the upside. And we need those kind of solutions to solve these problems, right? Technology providers banding together and integrating more. Somebody needs to step up to be the integrator. And then you need just more realistic kind of reward structures, risk and reward structures that reward people for investing in technology, new technology and new systems. And I hope that is happening. I see some really encouraging signs right now.
I do as well. And I would say this, we've definitely hit a hot button. There's a lot of people talking about it in the comment section right now, saying so true, exactly right. Now you are heading into really cool territory, and Eric is clearly aware of this problem. So thank you guys for tuning in to be a part of this discussion.
It needs to change, by the way, David. It needs to change, because if we're continuing on this road where the operators are the beneficiaries of new technology and the technology providers are not being paid for it, the operators are running the risk of bankrupting a whole bunch of their service providers, right? which is not good for them in the long run. It may give them some short-term gains, screwing down on the supply chain, right? But in the long term, it's not a good thing. So the operators need to kind of think about how we're going to let the service providers earn some money.
I mean, there we go. So he says there also has to be a conversation on the people aspect, which is true. There's another company. I can't find it. All right. Well, I don't want to keep you too much longer. Dr. Van Oort, thank you so much for being here and being a part of this. Any last words that you'd like to be able to share with everybody out there that's watching still?
No, well, thanks for inviting me. I've enjoyed it tremendously. I hope it was useful to people. Maybe we can do this at some future time again.
I would love to be able to have you on again.
Yeah, my guidance to people is follow your passion, do what you love to do, right? And you're going to be tremendously successful at it. Reinvent yourself now and then is a good thing. Right? It can be a bit awkward to get away from your comfort zone, but it can be tremendously rewarding. As I said, one of the best things that I did was decide to become a professor, leaving my rather cozy and well-paying industry job. So making those kind of changes in your life are a good thing.
And we've got everybody saying, oops, wrong one there. Thank you, Dr. Van Oort. Preaching to the choir. We've got a whole bunch of people saying thanks. So everybody that is watching still, thank you guys so much for being here. We really do appreciate it. Like I said earlier, be sure to tune in Monday, the 24th, 26th. I keep forgetting what date. Hold on, where is it? 26th. All right. Sorry, I'll get my dates right. Get your headset. Right. I'll post a link with the one that I've got that I bought off of Amazon. It's only like $20 or whatever. It's not super expensive. You guys can afford it. Plus, they're kind of fun to be able to watch other. There's like a whole YouTube channel dedicated to VR stuff. You can watch people with scuba diving. You can watch people doing extreme sports. Just tons of riding roller coasters, all kinds of really cool content. I've even got another channel outside of Gibson Reports. It's called Dent VR, where I have hooked up one of these cameras to some motorcycles as they were going through and doing some track days out at COTA. So Circuit of the Americas, not the end of a song. So be sure to check that out if you guys want to see some content ahead of time. But like I said, really excited. Catoosa. And you guys tune in 360 VR live from the rig site. First time ever being done. Really, I wouldn't say it's so much a stepping out of my comfort zone, but just really trying to push the envelope to be able to bring you guys something that's never been done before. So everybody, thank you guys for being here. We really do appreciate it. Ian, you guys say thanks. Isabel says thank you. LinkedIn user says thank you for an interesting session. Thank you guys all so much for being here. Next week, Todd Brooker. We're going to be doing, I got to click this off, otherwise it stays up there the whole time. Todd Brooker next week, learning about the money side of the business. And until then, everybody, know your industry. Did it not play? Is it playing? I can't tell. Hold on.